Okay, so today we're going to be looking at the female reproductive tract, and we have a pig tract here for you today. So here I'm just pointing out the vulva, and then we're going to the maternal vagina, the cervix, the small uterine body, and the large uterine horns. Get around to the oviduct or fallopian tube and the ovary itself at the end of the oviduct. Okay, so just change to the head cam now, and you can see I'm feeling along the vagina and the start of the uterine body, feeling for the cervix region. So the cervix is quite hard, a cartilaginous material in rings, which forms a physical and biochemical barrier for foreign objects wanting to gain entry into the female tract. And there I'm just pointing at the bladder, which is connected by a common opening into the vagina by the urethra from the bladder. So now what I'm going to do is to have a look a bit more detail at the uterine body and the uterine horns. Now you see I'm just opening up, and you see a see-through membrane which is called the broad ligament. This holds the uterine body in place within the female abdomen, and you see that it contains some blood vessels as well, but to dissect out the uterine horns and straighten them out, I need to cut away this broad ligament. Just carefully going along, cutting the broad ligament and extending out those uterine horns that are bunched up at the moment, to give you an idea of the real length of them. I have to be slightly careful when I come up to the oviduct, that I don't cut through it. Come to the end of the uterine horn, and you'll see a constriction at the end of the uterine horn, which will be the start of the oviduct. That constriction is called the uterotubule junction, and in pigs it forms another physical barrier that is used for sperm selection. So here I am just at that narrowing at the end of the uterine horn, which is the start of the oviduct or fallopian tube. So I'll just point to it in a minute with my scalpel. So that's the uterotubule junction. Now tease apart the oviduct, and I'll take where the ovary is. Now, the ovary is usually enclosed in a bursa or membrane, which contains the fimbria, which are finger-like projections which help capture the eggs at ovulation. What I might do is just remove the ovary itself. Nick the oviduct a little bit, but it should stay intact with the membrane attached to it. The oviduct now. Now the oviduct has three regions: the isthmus near the uterotubule junction, the ampulla region, and the infundibulum, which is next to the ovary. So in pigs and a lot of other species, fertilization occurs in the ampulla region of the oviduct. So this is where the egg and the sperm meet. Just teasing out towards the infundibulum region of the oviduct now, which is the start of that bursa or fimbria, which usually wraps around the actual ovary itself. Now I can show you the true length of the actual uterine horn, now that we've separated it from the broad ligament. So pigs are multi-ovulating and therefore multi-offspring species, so they can have up to 16 piglets, up to 8 in each horn during gestation. Just using my scalpel as a pointer, there's the ovary, the oviduct, uterotubule junction, and then the large uterine horn. fairly small uterine body. So I've just picked up the ovary that I dissected, and you may just be able to see some small fluid-filled vessels on the surface of the ovary. These are the follicles that contain the developing eggs or ova. So I'll just go for a wander over to the other petal where we've got some other species. I'm just going to quickly dissect out this bovine ovary, so cow ovary. And you should be able to see the difference. So we have a very large yellow body. This is a corpus luteum, so this has developed from a recently ovulated follicle or ruptured follicle, and under the influence of luteinizing hormone has developed into this corpus luteum, which secretes progesterone, the hormone that sustains pregnancy. Size difference between the cow ovary and the pig ovary. Cows usually only ovulate one egg at a time, maybe two. What I'm going to do is just dissect through, do a cross section through the cow ovary. Now we have the cow ovary in cross section, and you should be able to see that yellow body much better now. That is the corpus luteum, and then the rest of the ovarian stroma, which probably contains some very small follicles, because under the influence of progesterone from the corpus luteum, follicular genesis is being suppressed. Okay, going back to the pig tract. Now I'm going to have a little bit more look. There's the uterine body. Before it bifurcates into the uterine horns. I'm just going to open up the layers of the uterus. So uterine layers. So the outer layer, the perimetrium, gives structure to the uterus. The inner layer, the layer directly beneath that, is the myometrium, which is the muscle layer, which is involved in contractions at labour. And then the innermost layer is the endometrium, where the embryos will implant and form the placentas. So now coming down from the uterine body, we start to get into the cervical region here, and we can see the annular folds, or pulvini as they're called, of the cervix. So this forms the physical and biochemical barrier that any foreign body, including sperm cells, need to traverse through to get to the ova, which are residing in the ampulla region of the oviduct after ovulation. And now still coming down, it's a fairly long cervix, and we're now getting into the vaginal opening. Now, boars, male pigs, actually insert the tip of their penis into the annular folds at the start of the cervix, and the cervix actually locks onto the end of the penis. The end of the penis is what is called a corkscrew-like tip or end to it that enables the cervix to lock onto it, so the boar actually ejaculates into the cervix rather than into the vagina itself. Okay, so here we have a cow female reproductive tract. You notice the uterine horns are much shorter than the pig tract. You can see their bladder as well in this image. And if you look at the ovary again, you can see a corpus luteum just next to my fingers, and maybe one or two follicles there on the ovary as well. So what I'm going to show you next is a horse's ovary, and you notice three large empty vesicles. Now these are follicles. This ovary has been cut in half and the fluids come out, but this horse would have had three follicles. Now anyone that knows a little bit about horses know that you rarely get triplets, and twins don't often survive. But even if this horse did ovulate 3 eggs and they were fertilized, usually by day 20, they normally end up only having one live embryo anyway. So next I want to talk a little bit about the placenta. And animals like sheep and cattle have placentomes. Now, unlike the pig, which has a diffuse placenta which covers the inside surface of the uterus, the places of attachment between the fetus and the mother, these discrete places called the placentomes. So the maternal part is the caruncle, the fetal part is cotyledon, and they fuse together to join the blood supply from the fetus to the mother itself. And the next illustration shows the supply of maternal blood and fetal blood connecting together at those placentomes. So often called cotyledons or caruncles, but the cotyledon plus the caruncle is the placentome. And here we have a gravid uterus, which means a pregnant uterus, and you might just be able to see at the top the fetus, and this is a cow, so it's a little fetal calf, and below that you see a lot of little ball-like structures. These are the placentomes, so these are the sites of placental attachment between the actual fetus and the mother's uterine lining to form the blood connection between the two.